Have you ever stopped to wonder how it all works? Every single time you send an email, stream a video, or just browse a website, you are tapping into a hidden set of rules that lets data fly across. Think about a simple human conversation. It really has three basic layers, right? You've got the content, the actual words you're saying. You have the rules, things like, taking turns speaking. And then you have the physical part, the actual sound waves carrying your voice. Digital communication, as you can see here, is pretty much the exact same idea. But that brings up a really big question. I mean, how does an iPhone from Apple have a flawless conversation with a web server that's running software from Google on hardware that was built by Dell? With all these different companies and all these different technologies, how in the world do they all agree on the exact same set of rules? Here's the game plan for how we're going to figure that out. First, we'll talk about these rules. Then we'll introduce the master blueprints that make it all happen. We're going to follow a piece of your data on its incredible journey down the layers and back again. And finally, we'll see why this whole layered idea is just so important. The answer to that huge question, how everything talks to everything else, is a universal language. And in the world of networking, we create that language using something called a reference model. So what is a reference model? Well, you can think of it as a master blueprint. It's a standard way of looking at things that takes the incredibly complicated job of network communication and breaks it down into smaller, much more manageable pieces. We call these pieces layers. Each layer has one specific job to do, and it only has to worry about the layers immediately above and below. And this is why they are absolutely crucial. First and foremost, they guarantee something called interoperability. That's just a fancy way of saying that a device from any company can talk to a device from any other company because they're all building from the same blueprint. It also gives developers a common standard to work with, and it makes life way easier for technicians trying to troubleshoot problems. Now, when we talk about these blueprints, there are really two big ones you need to know about. On the left, you see the OSI model with its 7 layers. It's a fantastic, super detailed conceptual model that's just perfect for learning how everything fits together. And on the right, you have the 4-layer TCP/IP model. This is the more practical, streamlined version that the modern internet is actually built on. For our journey today, we're going to use that detailed OSI model because it really lets us see every single step of the process. So let's follow the data. Imagine you just clicked send on an important email. We are now going to trace the path of that email as it travels down one by one through all 7 layers of the OSI model, getting all dressed up and ready for its big journey across the internet. We start at the very top with layer 7, the application layer. This is the one and only layer you actually see and touch. It's your web browser, it's your email client, it's your messaging app. It's the interface that lets you create your message in the first place. Dropping down one level, we get to layer 6, the presentation layer. You can think of this layer as the network's universal translator. Its job is to take the data from your app and format it into a standard, common language that any other computer can understand. It also handles important stuff like encryption and compression. Next up is layer 5, the session layer. This layer is the conversation manager. It's the one responsible for opening up a communication channel, or a session, keeping that conversation going between the two computers for as long as it needs to, and then closing it down properly when it's all over. Now we get to a really important one. Layer 4, the transport layer. This is the quality control department. It takes your big email and chops it up into smaller, numbered chunks called segments. This is super important because it ensures that all the pieces can be put back together in the right order on the other end, and it also checks to make sure nothing got lost along the way. Okay, moving down to layer 3, we have the network layer. This is basically the global postal service for the internet. It takes each of those little data segments and puts them into a digital packet called a packet. And here's the crucial part. It slaps on the source and destination IP addresses, the full global address, and it's responsible for figuring out the best possible path for that packet to take across the entire internet. We're almost at the bottom. Layer 2 is the data link layer. So if layer 3 was the global postal service getting your package to the right city, layer 2 is the local delivery courier that gets it to the right building on the right street. It puts the packet into something called a frame and gets it ready for whatever physical network it's on, like your home Wi-Fi or your office's Ethernet cable. And finally, we hit rock bottom, layer 1, the physical layer. This is where the digital becomes real. This is the hardware. The frame of data is converted into electrical signals for a copper cable, pulses of light for a fiber optic cable, or radio waves for your Wi-Fi. It's the actual ones and zeros flying through the air or down a wire. And this whole process we just walked through, this beautiful system, has a name: encapsulation. As you can see, it's like a set of Russian nesting dolls. Each layer takes the data from the layer above it and wraps it in its own little bit of information, its own header, without ever changing what's on the inside. So just to quickly recap the lingo here, as our email traveled down the stack, its official name kept changing. At the top layers, it was just data. Then the transport layer turned it into a segment, the network layer made that a packet, the data link layer called it a frame, and finally, the physical layer sent it out as bits. All right, so our data is all packaged up, it's been turned into bits, and now it's flying through the network. What happens next in this great digital relay race across the internet? And here's the truly genius part of this whole system. As your data zips across the world, it passes through all these special devices called routers. But these routers are incredibly efficient. They don't have to unwrap all 7 layers of the Russian doll. Nope. They just have to look at the layer 3 header, see that destination IP address, and they immediately know exactly where to send the packet next. They never even peek at the actual data inside. And that layer 3 address is, of course, the famous IP address. That string of numbers is what makes the whole global internet possible. It acts like a unique street address for every single device online, guiding your packets from your network to their final destination, no matter where in the world that happens to be. So once your data finally arrives at the destination computer, the whole thing just happens in reverse. It's a process called de-encapsulation. The receiving machine starts unwrapping each layer, stripping off the frame header, then the packet header, then the segment header, all the way back up the stack until your original, perfect email data is delivered to the right application. So after seeing that whole complicated journey, let's just step back for a second and ask the really big question. Why? Why does this layered model matter so much? Why is this whole idea the true unsung hero of the internet? Well, this layered approach is the secret sauce behind the internet's incredible growth and its constant innovation. Think about it. A company can invent some brand new Wi-Fi technology at the physical layer, and it doesn't break your web browser at the application layer at all. You can design a brand new photo sharing app without knowing a single thing about how fiber optic cables work. This separation lets people innovate on one layer without having to reinvent the whole thing. It's what lets the internet evolve constantly without collapsing. And even though we use the 7-layer OSI model to learn, just remember that today's internet really runs on that leaner, meaner 4-layer TCP/IP model, which uses the exact same powerful philosophy. It's this elegant, layered blueprint that allows a chaotic global network of billions of different devices to work together with unbelievable precision. So the next time you go online, maybe you'll think for a second about that incredible invisible journey, that high-speed relay race that's happening right behind your screen, all thanks to these master blueprints of the internet.